Okay, so continuing in this problem, I had a little hiccup there. We'll just roll with it as we do. So you solve this system any way you can. It's not really important right now how to solve it. You won't get real messy ones in like an exam or stuff. In your homework, you might though. So practice it. Stuff comes up later. What I did is I put it into a matrix form. You may have seen this before in algebra or not, I'm not sure. So I put it into matrix form and solved. So I did row reduce echelon form, and you get the identity matrix, and then these are your solutions. So that means A is -5, B 3, C 1. I didn't show the steps, didn't want to use up too much time in the videos. If not, if you don't do something like that, then I would just take this thing and solve. And so you can like isolate A and plug it in here, or how, and then you end up with A and B, and then or I'm sorry, B and C, and then you use that to solve with this one, and you can eliminate or something like that. Okay, but there's methods that you develop to solve systems. You should know a couple by now. Anyway, this is row reduction that you see again a bit later in linear algebra. By the way, at least that's the initial concept you start with. Okay, so we have those. So let's go ahead and substitute into our formula or function. And so you get that this quadratic, and I'm not going to solve the expression this time. We're just going to show you what you get. I didn't mean to copy that thing. All right. So that equals all of this, and you substitute in your values. So you get the integral of A, which is -5, over the 2x minus 1, and then it's going to be plus 3x plus 1 over x squared plus 4 dx. All right, so then what you would do is continue to simplify this. You would say this is negative integral. Let's do -5, make it even better. So -5, and that's 1 over 2x minus 1 dx. And then it would be plus the integral of, I'm going to try to bring out those constants so you can hopefully see it better. The 3, and then x over x squared plus 4, and then plus, that doesn't require anything, finally, the integral of 1 over x squared plus 4. Man, dx. This is messing up a lot for some reason. Okay. What is it? Why is it doing this? I'm going to have to stop this thing. All right. Let me fix my technology here. Okay, that's a dx. All right, so then take a look at what you would evaluate. So I'm not going to bother finishing this one because you can check out a lot of stuff here. I have one more to go over. So this one, which form is that? Okay, that one is going to be a natural log, but you still got to pick your u to be 2x minus 1. And so your du gives you that 2. So you end up with a half out there. And then you end up with natural log. Okay, this one what can you do? Well, if you pick u to be that denominator, you're going to get a 2x, and so the x is up here. I knew I forgot something. I need a dx in there. Okay, I think it's time for me to quit. Okay. And so you end up with another 1 over u, which is another natural log, but the u is x squared plus 4. Okay, and then this one is what? Do you recognize that now? You have a square and a 4. What is that going to be? So 2 squares, what does that give you? Is that an inverse tan? Okay, so look that up. Okay, so I'll just say finish. Okay, so try to finish those. This is definitely the type of stuff we'd work on and then do this in class, because this is all the old stuff. This is the new stuff. Okay, let's do another one. And I didn't, okay. Let's do one more. This one won't take too long. So try this one. So you have the integral. So secant squared x over tangent x plus 1 dx. All right, so try that one. Let u be tangent x. Then du is secant squared x dx, which is right there. Here's your secant squared x dx is your du. So you end up with, when you do your substitutions, you end up with the integral of 1 over u times u plus 1 dx, which is exactly a partial fraction decomposition. So we'll say that's equal to the integral of a over u plus b over u plus 1 du. And then you would solve for a and b. All right, so let me just show you what you get. So check this. You end up getting a is 1 and b is -1. And your solution will look like this. It's natural log, absolute value of tangent x over tangent x plus 1. All right, so you can check that on your own and see if you get that. Pretty straightforward from there. Okay, that's all I'm going to do for partial fraction decomposition. In class exam, you know, I would never make it real complicated. I just want you to be able to apply it. Take-home type situation, it could be complicated, but you have plenty of time to work it out. Frankly, these questions are more tedious than difficult, I would say.